I'm Jeff Garland. This presentation is about the C++20 standard library, mostly not about ranges. And there's a bunch of other topics that aren't going to get talked about as well. I'm going to tell you what I didn't talk about, and so you'll at least have some pointers. I've been here for every one of these conferences, and recently I hadn't talked much, but more recently I've been able to get back into working on standards. And back in 2007 I helped with the original Chrono presentation and documentation, and so I'm getting back into it now, and I thought it would be useful to try and record everything that's going into C++20, even when it's not quite there. So we'll talk a little bit about that. Here's the list of goals. There's a bunch of stuff on I/O. New facilities there. FMT format is the big one. We'll probably spend more time on that library than anyone else. General support utilities, there's a whole list of smaller and medium-sized things in here. Flat map and span, some larger size containerish view type things. And then a bunch of things with containers and algorithms. There's a major update to Chrono, which I'll tell you about. And then some smaller stuff at the end. If we don't get to this stuff, we don't get to this stuff. But we will try to get there. So as I said, and as obvious from the title, the big thing we're not talking about is ranges. Ranges is a huge change to the library. It's a complete overhaul of the algorithms. I have a talk on that tomorrow. So if you're interested in that subject, I'll be covering that tomorrow. There's a bunch of other smaller things that I chose to just take off the list. Three-way compare support, any invocable, which is also called unique function in all the proposals to date. U8 string and string view. Constexpr, that's what this conference is apparently largely about this year. There's a ton of new Constexpr and various algorithms and containers. I'm not going to talk about it. I'm also not going to talk about noexcept. There's been a lot of parts of the library that have had noexcept added to them as part of the C++20, and I'm not going to talk about that. I'm also not going to talk about variant, algorithm vectorization, or atomic ref. Matus talked about those yesterday in his, and we just don't have enough time. Okay. So just to level set things I'll do and won't do in this talk, I'm undoubtedly going to show you something that will not be in C++20. So I'm afraid that right now, and I'm going to show you the state of everything as we go through this talk, there's a lot of things that are still in process. And I'm going to go through this a little bit more in a minute. I will take questions until we kind of get behind. And I think I have a pretty good idea how long this talk takes. So I'll kind of know when that is. I'm going to defer anything I don't know unless somebody in the audience knows, which is the typical thing here. And no doubt I'm going to get something wrong. This is just a very complicated set of facilities, and it would be impossible to get everything perfect. So I'm going to show you a lot of code. I'm going to shorten up namespaces. I'm going to leave out pound includes. I'm going to do a lot of that kind of stuff as usual. But I'm generally not going to show you something I haven't actually tried to compile. I'm going to tell you when I didn't try to compile this stuff. It's a little bit different for me. I like to try things before I give a presentation on them because I learn things about what they actually do that you can't seem to tell from the specification, strangely. So the environment I mostly have been using for this is Linux, GCC, 3 different versions of it, v9 trunk as of mid-March 2019. Normally I'm compiling with fconcepts and usually with C++20, not that that means anything right now very much. And in this case, for these libraries, there's a lot of different libraries. There's a lot of GitHub repositories that I had to download and get the reference implementation. I also mentioned to you that I spent a decent amount of time communicating with authors of these libraries because what you find out when you start digging into the status of all these things is that, well, there's a few things that aren't quite there yet. And so as best I could, I tried to get information from the actual authors where I could. So I think this is the best information that's available right now. So what's the implementation status right now? C++20 is feature complete. There will not be design changes except for in response to defect reports at this point. The Cologne meeting, which is in July, is the end. That's when the CD is going to ship and it is going to go. So anything that is not finished in that Cologne meeting in July will not be in C++20. I really like this CPB reference page. I don't know if you've seen this one. This is a very handy page to look at. It shows you all the language and library features across all of the compilers. I know all of the compilers have their own individual pages here, but those are also linked at the bottom. So this is like the one page for all. And I don't know how they keep this status up to date. I don't know if it's fully up to date all the time, but I encourage you to use that link. I'll also mention the current working paper. If you don't know about WG21 Link, that's Working Group 21. That's the C++ Standards Committee. And 4810 is the current working draft. I refer to that all the time. It's an interesting question. The committee likes to say that the standard is not a tutorial, but I say that it's very helpful to actually go and read the synopses and other things of the library components. Okay. So with that, let's dive in. So the first major component that we're going to get is std format. This is the FMT library, and it's really a Python type style string formatting capability that's being lifted into C++. It supports named and positional parameters, custom type formats, and in general, it's a much faster engine than IO streams with less overhead. And I'm also going to show you later today that the input-output for Chrono, which is a new part of C++20, is integrated with FMT, and that took some doing on the part of a variety of people. There's a new header for this, and if Marshall were here, he would say we're getting a lot of new headers in C++20, and that is definitely the case. Okay, so let's look at Hello World. This is a basic code. I've got FMT here because, of course, that's where the library is currently. These will all be std instead of FMT. You can see this is very simple syntax. You have curly braces in the format string, and then you have a variadic argument list that is matched up against those braced elements in the format string. So very simple. The parameters can be of any type. All of the standard types that you know and love will work out of the box. So I can do something a little different here. If I want to have a little bit of control over the order of the parameters, I can use indexed parameters. So in this case, we have two indexes, 0 and 1, because of course all indexes start at 0. And those are the positions in the argument list. So in this case, what's happening is 42 and hello are being swapped. One thing I cannot do is I cannot mix a non-indexed parameter specification with an indexed. So that will be a compile time error.
Question?
Yes?
What's the use case for being able to swap the things rather than just swapping them straight out?
I think the use case is probably internationalization because, of course, you don't have to pass this as a, const char star in the point of this. It can be something that's generated in a variable somewhere else, right? Yes, I should repeat the question. The question was, what was the use case for swapping, for example? Okay, so another capability that this has, it has the ability to actually name parameters. So in this case, we have two parameters, one named num and one named wrld. And then there's this little helper that's used, this fmt arg. And this arg in the list allows you to actually name the parameters. And so again, now what you're able to do is match in the format string a named parameter that's in the list. So this is going to give you some pretty sophisticated capabilities. Okay, we've got a question in the back.
Can the named parameter occur multiple times in the format string?
Can the name parameter occur multiple times in the format string? I do not know the answer to that. I doubt it, though. I'm not sure. We can check later.
The question, can we use raw literals for format string?
Can we use raw literals? That is actually a string view, and I don't know if a raw literal, I think that will convert to a string view, so yes. Okay, Chandler says yes, so then for sure yes. Thank you, Chandler.
You said that if we mix indexed and non-indexed parameters, you get a compile time error. But at the same time, you said that the format string can be fetched from external file.
Right, right. So the question is, how can it be a compile time error if it's somewhere else? And the answer is it can't be, and I'm gonna get into that in a little bit. Okay. All right. So what if we want to do indexed and named together? That's possible. I'm not sure what the use case for this is, but I assume this is a capability that Python supports for some reason. It's a capability that the library supports, and it is in the standard. Anyway, it gives you a lot of flexibility for defining your format string, and I will tell you that this is just the hair's breadth so far. And I'm not even going to get into the business of all the numeric formatting capabilities this library has. It is extensive. So let's talk about one issue that surely has come up in your mind is what happens if I need to put braces in the actual string? Well, so you get to escape braces by using another brace. So I guess we get to have fun with braces. So in this case, you can see when the format string is resolved, the untouched one of the brace sets is removed, but the other braces are escaped and remain. So basically, this prints right here. There were 2, now there are 1. This can get a little bit crazy because I believe this is essentially recursive. So in this particular case, what you're going to see is we're able to put 42 within this double brace, but it actually becomes a single brace in the actual output. And have fun with braces. So I'm going to give you one numeric formatting example. And I'm going to give you this one in part because it illustrates some other capabilities of the library here. So one of the things you'll notice here now is that we have a width and a precision. And so this is a floating point number where we basically want to say, 10.3f, right? So we want the format type to be like this. But you'll notice that in this case, we're actually influencing the internals of the format string itself by passing parameters in, okay? So you'll note that there are 3 indexed parameters here, 0, 1, and 2. And this is actually saying the 0th parameter, here's the format string, the colon separates it, and the 2 and 1 come from here and there, so you get 10.3f. Okay, so you have some very sophisticated capabilities to generate the format string even within the syntax itself. Okay. Custom types. So let's say I have a custom type. What am I going to do with that? Well, in this particular case, this type, the system doesn't know anything about it. It's not going to work. It's not going to compile. So how do you extend for a custom type? This can get interesting depending on how complicated you're trying to get. But basically in this case, what you are doing is you're making a specialization of the formatter. And that is going to have to return a formatter string view format, some machinery down here. In this case, all I'm basically doing is got a switch statement that changes the enumerated types into strings. And I'm returning that back, okay? If you want to have a custom language for your format for your special types, you can do that too. We're not going to go through that here. But Chrono is actually going to do that and take advantage of that capability. So there's a large amount of extensibility here for your own types as well. It's going to be different, and I'm sure it's going to take time for everybody to adjust on how to do this. Vittorio.
Does this find stream operator overloads? No. Does this find?
Does it find stream operator overloads?
Yeah, let me repeat that because I didn't talk it to the mic. So does this find existing stream operator overloads, for example, OStream?
No. But I'll show you some things where, so really what you're formatting into, you'll note here, is strings in general. But there are, I believe there is also a print function, and that can go to a stream. Okay, wait. Okay.
The library supports formatting using like the stream output operator. So if you have a type that has the stream output operator defined, then it's going to use that.
Is that right? Okay.
You need to include a special header, so it's
Okay.
not by default.
But I'm not sure that's in the standards
I'm not
proposal.
sure about that either.
Yeah, so we would have to check on that to be sure. I don't believe it is, but yeah, I'm not 100% sure on that. It's a good question. All right, so be assured you can do your custom types. So let's just talk for 1 second about performance here. Performance is always something that's important to C++ programmers. This is a little bit old, so it's an older version, but you could see that at least with FMT, there was a lot of care taken, at least in the integer realm, to try and make the formatting extremely fast. Lower is better here. You can see at the bottom, std toString and boost format, and I don't even know what compilers. There's the link at the bottom. You can go follow it and go read the whole blog post. This is Victor's blog post itself. And again, this is from a few years ago, but this is the kind of thing that we like to see where we're going to get highly optimal performance if we can. All right. So now let's talk about diagnostics and safety. So what can go wrong? Currently, all of the diagnostics here are runtime diagnostics, so they're exceptions. And in theory, if you write a, const char star format string, you can imagine that that could be runtime checkable. I think Hannah presented in the keynote almost all the machinery that would be necessary to do that checking. However, it is not the case, and it is not specified in the standard that that is what is going to happen. So what can cause an exception? So one thing is if you have the wrong count of parameters. So I'll show you examples of these. If you have names that don't match, if you have types that don't match, in all of those cases you can get an exception. We looked at this very carefully about whether we would put this into production, and we have held off because we're not sure we can keep ourselves from doing things like putting this in a catch block or putting it in an untraveled, untested piece of code that isn't going to be executed for a long period of time. That's the practical realities. So don't use it in catch blocks or other places that are not exception friendly would be some basic advice. Or you're going to have to wrap things in a try-catch. So let's look at them. Here's an example. I have 1 parameters. I have 2 format strings. It doesn't like that. Yes?
And again, the library supports compile time format strings checking.
It does not.
It does. I know for a fact.
Okay. Well, you and I can get out the compiler later, and I'll show you exactly what happens. I compiled all of these examples.
You need to pass it the string literal inside a macro. So fmt string,
sure.
the string literal,
Yeah.
and then pass that to format.
So
Then it's gonna work.
let's be clear. So the comment is that the current library supports it with macros. None of that is in the standard.
It's not yet.
I've had this conversation with Victor, and he very much wants everybody wants compile time checking of strings in this case. But of course, if I pass this as an argument that's a variable, it's not going to be possible anyway. But in the case where I've written it like this, clearly I would like to have that compile time checking. I think there's some general hope here in that the compilers already know how to do printf and some of these other things now. So they're doing some special things. Yes, Vittorio.
So in 20 we have, generalized non-type template arguments. So as far as I understand, there's nothing preventing us from having an overload that takes the string literal as a normal argument for runtime parameters and one that takes into angle brackets for compile time.
Yep. I'm not saying it's not possible. I'm just saying it's not specified.
It's not in the standard.
And it's not in the standard, and the implementers do not have to do that. So the interface is what it is until somebody implements it out. I think that we will get there. I mean, I'm convinced that there's enough people that want to use this kind of capability and that want the compile time checking if it can be done, and the technology seems like it's there. So, okay. Couple more real quick. I've got the name num up here. I got the argument name number down here. That's incorrect. I get an exception. One little pet peeve about the library doesn't tell you which argument mismatched. If you had a long string, that would be a problem. Chandler.
Really short comment about compile time checking.
Yeah.
Compilers can just add compile time checking.
So Chandler's comment is compilers can just add it. That'll be great. I sure hope they do.
Like with printf, you don't need anything else.
Yeah.
If this gets standard, like with the standard,
Yeah.
you can just go and add it.
Yep. Okay. So Chandler's saying we'll just go and add it. We're going to mark that down, and you'll get to implement it. You're going to regret saying that. All right. All right. Last one. This is a type-based one. And I actually, I was looking at Python for inspiration here, and I actually pulled out from this little tutorial an example. And there was an automatic type conversion here. You've got a floating point type and a decimal type here, 4242. Well, guess what? C++ won't do that conversion for you in this case, whereas Python actually will. There are other kinds of format strings in this library that will allow you to do some kinds of conversions. Okay, that's a lot. That's probably the most you're going to see on any library. But this one, I think, is critical for every C++ programmer. I'm sure every C++ programmer will use this. I would be shocked if they don't. So what is the status of this? P645 is the link. There's the FMT library. Go experiment with it. Be aware, there are things in that library that are not in the standard, but it's in LWG. It has been reviewed once and maybe twice, actually. So we've been working with Victor on trying to get the wording in line so it can be in Cologne. There's other things that I'm going to show you in a few minutes that are dependent on it. So I really think this will get in. Tao.
Quick question. So you're saying that the format portion of the format library made it, so the print versions didn't make it into the standard?
No, they're there. I just didn't show them to you. Yeah, yeah. It's a big library with a big surface area. So the question was, are the print ones there? And yes, they are. So.
Just a quick question on. Just a quick question on the type safety side. Obviously, from the example, into double doesn't work, but do the other integer promotion bits and pieces work?
Yeah, so the question is, will other integer promotions work? I think so, but I wouldn't be 100% sure. I didn't try it. So I'll leave it at that. We got two more here, and then we'll probably have to move on.
You mentioned performance. I assume that was runtime performance.
The performance, yes. That was a runtime performance graph. Your mileage may vary, but
Question is on compile time.
compile time performance. Yeah, listen, I compiled small stuff, and so I don't know that there's any metrics on that at all. I don't expect it to be a.
Project is at this point a few hours of compilation time. So
Okay.
if you're
So the comment is that he's got a few hours of compilation time, so he cares a lot. I don't think it's going to be a huge issue. Yeah.
Print is not in that paper.
Oh, it is not.
It is not.
Okay. Good to know.
Quick question. Will you take containers
Will it take containers? No. No. Okay. Let's move on. Sync buff osync stream. So in multi-threaded applications, it's very easy to get your streams garbled up. If you're sharing a stream between threads, you can definitely get yourself into some trouble. There's a long history. I think it was mostly in the concurrency working group. They were working on this issue. Many people have run across this issue. There's probably 5, 6, 7 papers associated with what should we do with the library to solve this. So what you're going to see today is the solution that came out, and it allows you to wrap up a stream and have an independent buffer and then synchronize the transfer of that buffer into the underlying stream appropriately. There's a new header called sync stream. This is what the code will look like. And I will say this one I did not compile. So this is something I just worked with Peter on. But anyway, it looks like a stream like any other stream. Osync stream, but you're wrapping up, in this case, cout, which is a contrived example, because I think in most cases cout is actually probably pretty safe anyway, in that the C synchronization winds up synchronizing, but in any case, other file streams in general are not protected. So this buffered output object here has its own internal buffer, and even when you do an endl, which is going to flush the buffer here, it's not actually going to flush to the cout at that point. Okay, it's only going to flush actually when it's destroyed, and there's actually an underlying call called emit, which is the thing that flushes it to the underlying stream buffer. So here's a different little example. There's some other little utilities you can change this behavior. So here I've got a file stream, an output file stream, and I'm going to wrap another buffer around it. That one wouldn't compile probably because of scoping, but in this case, there's another function here called emit on flush, and that changes that endl behavior. So emit is called when you do flush the buffer. Was there a question? Ah, yes. You're hard to see in the lights.
Can you return to the previous slide, please?
Yeah.
So in the first example, if I want to sync cout, should I have just one object of osync stream for whole program, or should I have, or can I have like multiple objects?
Yeah. So the question is, can I just have one object, or do I have multiple? You're going to have to do that everywhere, right? Because they're going to have to synchronize against each other. So I think you're going to have to do that everywhere. And so I don't know that the solution is going to work for everything, but I think you can imagine, for example, just as an example, we have a logging, thread-safe logging library, and we have to synchronize multi-threaded things. This kind of facility actually would probably do most of what we need to do. Another question.
Is this emit function no except?
I do not know the answer to that. The question is the emit function no except? Probably it is, but I don't know for sure. We'd have to go look at it. Pull up the standard, you'll find out.
Yeah, so,
Oh, that's a good point.
My question's related.
The point was, just let me make the point. The point over in the audience here was, well, it's going to run in the destructor. It better be no except. Yeah, okay.
It doesn't seem to be intuitive reference.
Okay. All right, well, interesting.
It says, it calls emit on destruction. If an exception is thrown by emit, it is caught and ignored.
Okay, so it says that it catches the exception and ignores the exception if it's thrown. So it's effectively no except. So here's a more realistic kind of example where you might apply this. Let's say you've got multiple threads, and you're going to do some kind of function here against the file, and you're going to do a bunch of complex code. So this osync stream is only going to flush when you exit this function. So just a little bit more realistic motivational example. This is what the header kind of looks like. standard kind of stream header. If you've ever looked at these things, you get basics versions of things, and then you'll have the usings for the various char types. So standard streaming stuff. This is in the working draft already, so this one is going to ship. And there's the references to implementation and so forth. Now, Peter told me that in general, you really kind of need your library vendor to really do this well because of the internals of the streaming and so forth. So, you know, you're probably really going to have to wait until this comes out in the compilers and standard libraries. All right, the next library is another little streaming utility called OStreamJoiner. Again, it's a wrapper around a stream, but it takes a delimiter, and that delimiter is then interspersed between the values that are inserted into the stream. Okay, and it has the interesting behavior that it has the ability to not insert after the last one in the stream, which is very convenient if you've ever had to write the code for, say, you know, JSON streaming or so forth. And it acts like a normal stream, just like anything else. So here's a little bit more interesting example I wrote just to try it out. I've got a function here that takes a container type, and it takes some delimiters, and it takes an OStream. And so this allows me to just print out any kind of container that I want. And what I do first is I insert the start delimiter into the stream. And then I construct an OStreamJoiner with the delimiter that's passed in or defaulted, as the case may be. And then I just copy the entire thing into the OStreamJoiner, which pushes it into the underlying stream. And then I put the end delimiter on and return the stream.
You don't need the flush?
Nope.
In this one, you don't need OJ flush?
Nope.
That means... Okay.
So the question is, do I need to flush here? And I don't believe that would be the case. It may flush under the hood, and I don't know that, so that's a good question.
I think the point is, what about the lifetime of the delimiter?
Mhm.
Is it gonna...
Well, the delimiter, yeah, so what's the lifetime of the delimiter? The delimiter is obviously going to be gone at the end of the function.
Yeah, so it's gonna be put into the buffer even if you don't flash. Like it's gonna be written to the buffer.
It's going to already be written, yeah. Yeah.
That wasn't my point.
Oh, sorry.
What I meant was that you have two different variables writing into the same OS in that example. And when you do OS and it's not obvious that OJ
Yes.
puts everything to OS.
Right. So the point is, if you had two different, so this is assuming exclusive access to the stream. So
Not what I meant.
what's that?
Who pushes the last curly bracket? Is when the joiner gets destroyed, or
The last curly bracket is in this code right here.
Yeah, and the question is,
Well,
at that point, did
not
OJ already write everything to OS?
Yes.
That was my point.
At that point, yes, OJ has already written
That
everything.
means that every call to OJ, every insert that you do to OJ, it immediately forwards to OS.
Yes.
That,
Yes.
that's somewhat surprising.
Okay, so this is what the code actually looks like. So vector strings, vector events, etc. It just prints out some nice stuff in the case where you give it some kind of empty collection. You know, basically you get braces, empty braces. And, you know, because I'm returning the stream, then I can stream stuff right into it. So, okay. So references. This was actually in the Fundamentals 2 TS. Michael Spertus has the example on GitHub, which I was using. There's some CPP reference information on this as well, because it was in the experimental. I don't know if anybody actually implemented it. I didn't really go look and see if anybody had implemented in their compiler and so forth. Okay. We're running just a little behind, but we're doing okay. So flat map and span. So flat map is really four things. It's flat set, flat multiset, flat map, and flat multimap. And despite what you might think, these are not actually containers. They're container adapters. And they are an alternative to the standard set map and multimap. And actually, this actually goes back a long, long time. It goes back more than a decade. There was an interesting discussion, I guess, by Matt Ostrin, who I believe was the library working group chair at the time. This is the second time I brought up Matt Ostrin at this conference. And he discussed the fact that no one should actually use set. And his point was that node-based containers and red-black trees weren't the only way to get good find performance. And in fact, there are alternatives. And that's exactly what these container adapters actually provide. So this is really about a different set of performance trade-offs. And we'll see some graphs on that that you get a very different thing. So let me just put this very annoying operating system, you must upgrade away. Thank you. So one of the things this does is it separates the storage for the keys and the values, even though the interfaces look very much like what you're used to. And if you have some kind of a mostly read associative container, you'll see that these are really good. They're not very good for something that you're going to have to insert into a lot. So let's look at what the performance looks like. These come right out of the paper. Zach Lane, who's here at the conference this week, you can talk to him about this if you want. He generated these graphs. I took one subset of the graphs out. Basically what you have here is you have Boost Flat Map, which is not exactly the implementation of this. STD from GCC, STD map from GCC, and the Split Map T, which was Zach's little wrapper version of things. And you can see in this case of iteration, this is a huge win. You have a flat line versus a very high slope as the containers get big. By the way, this is on a log scale, so be aware. So this is where these container adapters really shine. The find performance is interesting. It's relatively same. I'm sorry, the other thing I should have said is, I didn't annotate this unfortunately on the graph, but the left-hand side is an int-int mapping, and the right-hand side is a string-string mapping. They're not really that much different in these graphs, but just so you know what we're talking about here. So this is the same thing again with find. So of course this is the key thing that you're going to do with maps and sets and so forth is do a find. And as you can see, the performance is somewhat similar, and you can see at the end there in the right-hand side, the standard map is falling behind by a relatively substantial margin. I think from a theoretical point of view and from a practical point of view, I wouldn't trust that you're going to get better performance on find, but I think you can trust that the performance is going to be similar in nature, and perhaps even better in certain circumstances, and I'm going to show you why in a minute. And then of course there's insert. And we have the exact reverse here, which is to say that standard set rocks or standard map rocks and flat map is a disaster. It's very slow. And that's because it has to reorder the internal collections. And I'm going to talk about that in a second. So the performance comparison, these are going to use contiguous memory as their underlying storage. So in general, you're going to get a lot better cache performance on modern processors. We saw the iteration was faster. You're typically going to have a lot less memory allocations, and used in certain ways, you'll have none. And in addition to that, you're going to get reduced memory consumption because you don't have the overhead of red-black trees, node-based container, which takes pointer space for every element that you put in. Faster lookup? Maybe. Definitely slower insert and erase. So what does the interface look like? Very straightforward. You could put, STD map there and it would be the same. Okay. And here's a little taste of ranges for you. There's iterating over a range in reverse and printing it out. Okay. So, interface comparison to standard containers. first of all, the iterators in these are random access instead of bidirectional. And that's because the underlying storage is contiguous for keys and values, and the keys and values are separated actually into two different underlying collections. We will see that in just 1 minute. The iterators, which you might expect to be stable in a regular map in the face of insert and erase, are not going to be stable here. So that's something that is a definite difference in the interface that you should be aware of. In addition to that, the types are going to require to be copyable or movable, and again, that comes from the underlying storage as compared to the storage in a standard map. And the flat maps and flat sets are going to give you some additional capabilities here to extract the underlying container, to replace the underlying container, and to do some interesting things that you wouldn't think about. And Zach tells me that in the very first review he got of this paper, some game industry people told him, well, you're going to make the containers of the keys and the values separate, right? Because that's how we always implement that, right? Because it's super fast and that's the best way to do it. And indeed, that's where we are. So one other note, if you're thinking about using incomplete types because you've used Boost Flat Map, which definitely supports incomplete types, there's no fundamental reason why these adapters can't do that, but the underlying container types are going to have to allow incomplete types. So if you're going to use like a Boost stable vector as your underlying container type, then we think it will work. The standard doesn't say anything about this, and of course, this is an old long history item as well. Vector probably should support incomplete types, but it doesn't and it never will. So the standard version of this won't support incomplete types, but you can probably get a version that will if you want it. So here's what the flat map looks like. It's got a key type, a value type T, just like you'd expect from a regular map or set, a compare, less, so forth, so you can change that out. And then there's the two new ones, the key container type and the mapped container type. And you can see those default to vector of key and vector of T. So I could not compile this example. I don't have a reference implementation that does this. That's a little bit of a problem. And Boost Flat Map, for example, does not actually do this currently. And I don't know what the status of it doing it is. But in any case, what we've done here is we've got a vector of string, a vector of int. Interestingly enough, when you construct this, it's going to sort those. That may not be the behavior you're thinking of when you're providing it the collections that you actually want to use. So this is, again, why this is an adapter, and it's a little bit different from that perspective. So let's say that you already knew that those containers were sorted and matched up with each other the way you expected. Well, you've got another constructor here which has this sorted unique T that you can pass, and at that point, it just moves the containers in. So there's no allocations, it's constant time, and you're good to go. So this is why I was saying, if you can pre-build it up yourself, you know something about your domain and you can build up the map yourself, you can get really quick performance. Okay, so where are we at with this? There's actually two different papers. R6 is the latest one, and it's in the post-Kona release, that's 0429. That one has been reviewed by LWG. 122 actually has the set pieces of it. That was done by LEWG at the last meeting. That one has not been looked at by LWG at all. Arthur O'Dwyer, who's here at the conference, not in this room, I don't believe, he has implemented flat set on his own. He's got his own GitHub. I did not try that out. Boost Flat Map is playing at the edges, but not really supporting this at the moment. And there's that reference to what Matt Ostern had to say a decade ago. Okay, any questions? Yes.
My question, do you think that name of flat map will confuse programmers who also program on JavaScript, Java, or use some reactive programming, where flat map it's name of operation, not name of container?
Right. So that ship has sailed already. I know that functional programmers don't like the fact that we use map in general, since that's a function, of course. And so flat map, making it worse at this point is it's water under the bridge, I think. All right, let's talk about span. So we had a little conversation in the presentation yesterday. Span is an interesting thing. It's sort of a view, but you'll notice it's not called span view, and that's in part because it has the ability to modify the underlying sequence. And so I think out of abundance of caution, it was going to be the case that constness and a lot of other things could get a little weird here. So we didn't really want it to be a view, even though that's really what it is. It's really a way to look at a sequence, and it's super cheap to copy because, of course, it's just a pointer and a size, really. And really, all of the functions on it are constant time. So there's nothing about span that's yeah.
How does it relate to the new category of contiguous iterators?
How does it relate to the new category of contiguous iterators? Yeah, it has contiguous iterators. So the begin-end functions on this will give you those, yeah. So yes, this is another assumption that you've got contiguous storage as your underlying thing, so it's going to work with collection types that are of contiguous memory or contiguous storage. I already said that. This is also constexpr ready, so you can use this at constexpr time. Let's take a look. What do I have to do to construct one of these things? I got a vector event. If I want a span event, I can just construct it directly. I have a little bit of a difference here. I have an array of size 5. I can wrap a span event around that. I can wrap it around a C array as well. That's nice. So I can get nice type safety when I call a function. I can also have strings and other types. So I think where this is really going to shine, where you're really going to see this get utilized in a case like this, where maybe I want to just have a range come in as my parameter. And so I'm taking in this print reverse here a span of int, and I'm taking it by value. And what do I have to do here down in my main? I've got a vector event. I just pass the vector event right into the function. Yes?
Does CTAB work with span? Or do you have to specify the template types like you do?
Right. So the question is, does CTAD work with span? I don't see any reason it wouldn't. I don't know if those are specified. Yes.
Could you show previous slide?
Yeah. I didn't try it. So.
I'm wondering how it will work with array strings. String may contain a pointer to a data where text is located.
So
will it be contiguous region in memory? I think no.
Yeah, this is an STD array, which is going to be contiguous.
But strings, it will be array of 2 strings.
Right.
But text may be located anywhere.
Oh, I see what you're saying. Yeah. It's a good point. Yeah, that's a good point too. So the comment is the strings are still contiguous, but yeah, they're actually like a subpart of the view in this case. Just as another note, I'll just mention yet another little piece of range code here. Once again, I've got reverse view here for whatever reason. I'm really in love with that. At the bottom here, I'm doing a couple other functions here. You'll note I've constructed a span here, and then I get the first 2 elements out of the span and send it to print reverse. So I got 2 in 1 that comes out, and then in this case, I go to get the last. So I can subset the span to smaller sections. This is a big class. There's a lot of things on it. We obviously don't have time to go through all of them, but it supports begin-end interfaces. It supports operator square brace, and that's where you can get into mutating. So you can index through. You've got data, size, empty, and a whole other array of things that you can do to this. There's also this variation with static and dynamic extent. So you can specify that the size of the span is only going to be 5, and then it's going to have to match up with other things that are size 5. Okay, so this is already in the working paper. There was a tremendous amount of debate about span across many meetings about its nature, should it be regular, what does the size return, etc. You know, you can talk to us offline if you really want to know all the gory details, but I think it'll be fine. All right. One little bonus with span. Oh, sorry, we got a question down here.
I'm not sure I get the constantness of this thing. So as far as I see, it's always const because it's a view, it's a reference.
It's actually not const really at all.
But
if you look at the constructors, it actually takes everything by non-const.
What I'm trying to say is, if I want to prevent mutation, can I say a span of const int?
I don't believe you can.
I thought you could.
That would be insane, because I can never have a view-only span.
Maybe you're right. Maybe the recent changes actually make it so that that will work. But in general, the constructor for span takes the collections not by const. So in general, that would apply to me. That would imply to me that the underlying collection is going to be modifiable. So yeah, maybe if you construct a const one, it's going to give you a problem. It'd be an interesting thing to try. It's worth trying.
Okay.
Yes.
Can the line pointers be something else than pointers?
Sorry, can align pointers?
So span
Yeah.
internally would have pointers.
Yes.
Right? Can it have iterators instead?
So the question is, can it have iterators instead of pointers? I don't think so. I think it has an iterator, or it has a pointer and a size. And actually, there's an overload for taking a pointer on the constructor instead of a collection. All right, I think we need to move on. So quickly, there's a little bit of bonus territory for span. So span has already gotten used, and this isn't in the I/O section, but it's actually about I/O. Who knows what STR stream is? Oh, wow. There are people under 25 in this room that know what STR stream is. I'm impressed. I thought you had to be as gray as I was to know what that was. So STR stream is the please deprecate it set of standard I/O that's been deprecated for a long, long time. But there's been this problem because there's a group of users that use the one feature of STR stream that is not in string stream, and that is specifically that you can construct a stream with a buffer. And so there's a new capability called SpanBuff and span streams that go around it, which allow you to use a span, essentially a span of char, as your input for a stream. So if you're doing things like, oh, I've got, a C array of chars and I want to use it nicely and safely, you can do that. So this one is Library Working Group for Cologne. So it's one of those that's on the bubble. We don't know if it's going to get in. Again, this is Peter Summerlad. He is here at this conference. He's the guy with the hat. So if you want to talk to him about this one, you can. Almost at the destination. All right. So I think we're going to have to pick up the pace. So we'll probably be skipping a few things here and going a little quicker. So there are a whole series of small container and algorithm updates. Let's cover them very quickly. First and easiest one is contains for maps. Yeah, it's easier to read m.contains than that not equal to end stuff. So it's very simple. This is added to the associative containers. For the associative containers like set, multiset, you actually have two overloads. You have the regular key type version, and something that can actually be comparable to key type will also work. FlatMap and its ilk also have these already. For the unordered collections, there's only the single signature, for contains because of the hashing. So there's your reference. This is in the working draft. you're going to get that. Heterogeneous lookup, I'm not going to go deep in this, but basically this is allowing you to have a compatible hash function for different types like string and string view. Const char star is a canonical example. So if I want to be able to do these finds and compares, normally today what happens is you're going to end up with a string view being constructed into a string, and that slows down the performance. So I'm not going to give you the example of how you write this, but this gives you the capability to make those conversions without actually having to construct an actual string. So this is in library working group for Cologne. There's the paper number. I did not have a reference implementation for this one. Uniform container erasure. So who's ever had a problem trying to erase something from a container? Anyone ever made a mistake? Oh my. Okay, most of the room went up, so you know there's a problem. There's an idiom, there's a way to do it. Fascinating read in the paper how many trapdoors there are. There's a huge number of trapdoors. And I think the Microsoft guys basically said this is one of the most common requests we get is some way to actually erase containers. So this is somewhat novel, actually. What we're going to have here is actually collection-based algorithms, which is something the standard library does not have currently. These aren't really range algorithms, they're really collection-based algorithms. And so anyway, this makes perfect sense, right? Erase if. I've shown you the list variant of it here, but it applies to all of the sequence types, basic string, dec, list, vector. Erase if can also apply to the map and the multi-map case. Oh, by the way, erase if is one of the cases where, or one of the places where there's a lot of the holes when you're using remove if. And the associative containers already have an erase key type, so that one is not included. So this is in the working draft already. And this is lifted from Library Fundamentals 2. I did not have a reference implementation, which is kind of a... Yes. Yeah, so there's a template signature for all of these containers. Yes. So there's an erase and erase if for all of those container types. Yeah. So pretty much whatever container you have, you should be able to call that erase. If you have your own container, right, you can obviously write your own. Yeah, you're going to have to. Yeah. Okay. So one other quick thing related to removing. This is a very small change. List and forward list, we're throwing away information and remove if, and unique. Whereas a little inconsistency with map and set that didn't do that. So now you can actually get the count of the number of elements that were removed when you call these functions. And in some cases, it may be very important to actually know how many elements were actually removed. This is in the working draft. I didn't have a reference implementation. Comparing containers. So it turns out that this comes from Marshall Clough. He was doing some work on unit tests and really got frustrated with trying to compare various kinds of containers. So like he had an array, STD array of 5 things and an STD array of 6 things, and you can't call equal on those two because they're different types. It's kind of nonsensical when you think about it because as it turns out, we actually have a comparison algorithm that actually works quite well in the face of this. So STD lexicographical compare is really what this is, underpins this. And basically you're getting a series of equal and greater and less and not equal on containers to enhance your ability to just compare containers. So it impacts the list of containers at the bottom there. And so it's using lexicographical compare under the hood. You should take a look at that algorithm if you're not familiar with it. It's very interesting. There's the link. It's Library Working Group in Cologne. I don't know if Lib C++ has shipped it yet, but they've at least implemented it. Okay, a couple more quick ones. Shift left and shift right. So these take, these are standard algorithms. So these aren't range algorithms, but there will be range versions of them. They're standard algorithms that just got added. So they just move the number of elements left or right in the sequence, and they return an iterator to the shift point. I'll show you that in a second. So here it is. I have a vector of int. I say shift left with the begin end, and I say shift 2. And it's interesting because nothing is harmed here. 4 and 5 are still there, but then 1 and 2 have been destroyed by 3, 4, and 5. So you've been shifted left. And the iterator is pointing at the 4 here. So coincidentally, if I call erase to the end, I can conveniently erase the rest if I want to. But in general, the size of the collection is left untouched. So if you actually just iterate over that collection, you'll get 3, 4, 5, 4, 5. Okay? So be aware of that. Shift right is basically the same thing. So there's the signatures. This is merged in the working draft. There's a GitHub for the shift proposal that I used to test this out. There will be ranges versions. That is in work. It's through LEWG. It is to LWG. I believe we have looked at that paper one time already. But there's a series of other additional range pieces in there. All right, I'm going to skip over find last because I'll talk about that tomorrow. So general support utilities. And I'm going to we're probably going to skip, let me just poll the room. Who does bit manipulation in this room on an extensive level? Wow. I guess we're C++ programmers. Who does object-oriented programming? I'm surprised. Well, okay. Okay. Well, we'll see what we can do. All right, so smart pointers. These are quick, simple things. There's atomics and default initialization. There's a lot of discussion about how should we spell atomic shared pointer, atomic weak pointer. There's some things in working or in TSs that spelled it differently and so forth. In 20, you're going to be able to say atomic of shared pointer of T if you want an atomic shared pointer. So that's very nice. This is merged in the working draft. I don't know that there's a reference implementation for this anywhere. I didn't look carefully in Boost, but there's the paper. You can go look at it. Another change to the shared pointer is allowing for default initialization. This case comes up especially when you have array types and you're going to initialize them right after you make them. And so in that case, you do not want the default initialization that you have of make shared or make unique. So here's what it looks like. You call this make shared default init. So that buffer of 1024 doubles that you just made will not be initialized in any way, shape, or form. Okay? It's just going to give you the memory for it. And now it's your responsibility to go initialize that memory and use it appropriately. So this one is merged. Boost Smart Pointer supported it since 156. All right. Functional programmers, I forgot to ask. We got functional programmers in the room? Okay. All right. So so this paper adds monadic operations. So we know we're in functional land right away for optional. There's 3 template functions added to optional: and then, or else, and transform. And these enable a nice, interesting functional style. I'll show you an example. I did not compile this one, so this one, is just an example. This comes from the working paper, but basically here you've got a string, an optional string that's 10, and then you take the optional string and say, and then change it to an integer, and if it actually changes to an integer successfully, then transform it by multiplying it by 2. So you can chain the operations as long as you want. As soon as you get a null op, you will not go any farther down the chain, and you'll return null optional. Okay, so a very interesting way to be able to chain operations together. We're starting to look like JavaScript, so there I said it. So this is a library working group for Cologne. There is an implementation out there. I didn't really play with it too much. Polymorphic value. Though this is for your object-oriented programmers. This is an interesting type, and I highly encourage you to read this paper. This paper is co-authored in part by Sean Parent and some other very good people. It's kind of like an any for polymorphic type. I don't really like that characterization though, because really what we're trying to do is we're trying to create a polymorphic object that has value type or regular semantics. That's really what we're trying to do. And so you're basically going to have typically a base class and derived types that you plug in to this thing. And I'll show you a little bit of an example. We're going to go through it real quick though. One thing to note is that there's no standard hash for this. So if you're going to use polymorphic objects with hash containers, you're going to need to write hash. But of course that makes sense, because how would the standard know how to hash your types in this particular case? So here's kind of the motivating example, and they do a really good job of going through this in the paper itself. I have a composite object, and I have a couple of components that are pointers to a base type, and I want to just construct them, manage them. I want this composite object type to be a regular type. What do I need to write? What do I need to use? Do I use unique pointer? Do I use shared pointer? What are all the things that I need to use? It turns out to be shockingly hard to do. And so this is the gap that polymorphic value provides. It allows you to write something like this, polymorphic type, and your type as members, and then all the regularness and all the goodness of regular types comes along for free. And so that's really what the use case is here. Like I say, look at the paper. There is a GitHub here. This one, somehow I missed the status, but I know it's library working group for Cologne. Stack trace. No questions on stack trace are allowed during this session. You'll have to talk to me afterward. We're down to 22 minutes and we got more to do. And stack trace is obviously one of these questions comes up a lot because there is a language footprint here. Core had a lot of conversations about this. I'll tell you that there's still interesting conversations on the reflector about certain elements of this and exactly how they should be written. But basically this is based on Boost Stack Trace. There's a new header called Stack Trace. And of course, if you're a C++ programmer as long as I am, you've already written one of these and you want one in the standard because you don't want to have to maintain the lousy one that you have for the last decade. And you're hoping that the compiler vendors are going to do good things for us, Chandler, thank you, and make sense of this. But obviously what you're going to get out of the stack trace is going to depend on, you know, many elements in the environment that are beyond control of the standard, like what mode you're compiling in. So simple use case, construct a stack trace, and it's going to give you the flow of execution to that point. Really, the simple way to think about the stack trace is it's really a container. It has stack trace entries. I think that might have been renamed actually, but anyway, a description, a source file, and a source line are basically what it is. And I think the reason I'm thinking this is renamed is because there's a thing called source location, which is set to replace it, that also comes out of contracts. So this is still a little bit in flux. Another method I'll point out, so that I showed you the O stream, but there's also a toString. So, you know, if you want to log it, you want to put it in other places, you should be able to do that, hopefully. All right. Again, on the bubble LWG in Cologne, I don't even know if we've looked at this one time. I think I'm going to stop and go past unreachable. Wow. Yeah. Well, I was going to mention one funny little thing. So if I show you this signature, is there anybody that doesn't recognize what this is? Anybody that's locked into an earlier version of C++? I'm sure there's got to be a ton of you guys that can't use this. So this is an attribute, right, which is a C++ 17 feature. And it's a language feature, right? But one of the things that's happening is that there are more and more attributes being created and utilized. And one of the new ones in C++ 20 is no discard. And there's a paper that puts no discard on a lot of different functions in the library, particularly things like empty and new, where really you always are going to use the return function from new, right? I mean, you always have to. Yes, question.
Like attributes have been in the language since 11.
Is it 11? Okay, my apologies.
But like I think.
But I guess my point
no
was.
discard came in 17.
Yeah.
But like no return was in 11.
Yeah. I thought no discard was 20, but maybe it's just the adding of it to these standard library functions. It's in 20. Sorry. Yeah. Yep.
Comments about it. So I've seen code where you have a static variable is initialized like by you, but like it doesn't assign anywhere. Like you use just like for the whole program duration. So actually you don't want to deallocate this memory because you want to have it until the program ends.
All right, so the comment is that you don't necessarily want to always just deallocate memory for some particular reason. That doesn't mean you shouldn't assign it to a variable, which would be what would stop the compiler warning that's going to happen. All right, let's talk about Chrono. We have 18 minutes. So we might not get to all the bit things. We'll see. Talk briefly about Chrono. This is a huge upgrade for Chrono in 20. This extends the existing capabilities of Chrono well beyond time points and durations and such into calendric functions. And really one of the new bridges that Chrono crosses here is there's now a whole series of types that are what are called field types or structure types, like year, month, day. It's just exactly what you think it is. It's a structure of a year, month, and a day. And these types have a special kind of function. Mostly they don't do a lot of calculation. Mostly they're there for I/O and getting things in and out of a particular type. There are some calculation functions that go on there. But there's the calculation types, or the serial types, I think is the way Howard puts this. So like sysdays, time point, seconds, these are actually really integers usually under the hood unless you make them floating point, which you should never do, but that's another story. But anyway, so these types are very fast. They're very small in memory. You can store lots of them. You can do lots of computations, additions, subtractions, and so forth. Okay, this is fully constexpr ready, which is really cool. You can construct times in a consistent way at compile time. Okay, so some simple examples. Here's a year, month, day. If you go to Howard's website, he's got hundreds of examples. In this case, you have to do a little bit of work to get the year, month, day to construct this way. But then you can construct a sysdays from year, month, day. You can do stuff like add weeks to it. You've seen this in Boost Datetime if you've ever used that. Same kind of capability. And oh, look, wait. Whoa, you OStreams. You were able to stream it out. Nice. And that's really the biggest upgrade. Couple notes. Chrono's error handling as compared to Boost Datetime, which uses exceptions, is very different. Chrono will allow you to construct values and interrogate values with an OK flag to find out whether or not you've done something that you shouldn't do that's out of range. That's a very reasonable design decision, and it also puts a little bit of burden back on users to make sure that they're doing things. So if you don't care about weird values coming out of your dates, fine, don't check OK. But if you do care about that, you might have to check the OK flag on some of these types. Okay. Part of the advantage of doing it this way is, again, it makes constexpr really possible. Okay, so Chrono I/O, I'm going to go through this really quick. We're not going to do too many examples. Here's a year, month, day that's constructed, and now I want to format it. Look, I've got std format here now, and I've got, interesting, what? I got sprintf type characters here. I've got %m, d, %y, so that's the foolish American way of putting dates. And so I just put that in. And this is actually using those extension facilities to expand the grammar. That grammar is extensive, okay? There's a very, very large grammar. It's kind of like what Boost Datetime has, but Howard's Library also has had this for a long time. So it's very expressive. You can create almost any kind of date and time string that you want to with that grammar. Not everything is possible. I know that for a fact. There's also optionally locale-aware time specializations. So I'm showing you something that we're not going to talk about more, which is zoned time, which is a time zone time. And in this case, we've gotten a locale and we've put it in. And that was an extension that Datetime got into Format. So this is an optional capability with Format to use the locale for that. And that's really important for dates and times if you've ever done anything where you need to localize the times. Okay, there's a ton of other features in Chrono. It's really a talk by itself. Leap seconds, time zone database support, localized times, GPS clocks. Go look at it. It's fabulous. It's the library we've needed for 10 years at least. Okay, so references. It's in the working paper except for this Format part. So, give love to your LWG members to get all this stuff in. But look at CPP Ref. It has a pretty good breakdown of the format strings that Chrono supports. Okay, bit manipulation. Let's see. I got 12 minutes. And so I think I'm going to just go super fast. There's a new bit header in C++20, and it has a number of different low-level functions that will be useful for some group of people. There's power functions. I'm not going to go through them. You can go look at the paper and read it. There's rotate functions, counting functions. These are actually not in. The power functions are in the working paper. These functions are not in the working paper yet. I don't think there's going to be any issue getting them in. So there's a couple reference papers on the bit manipulation and status. I'm going to skip over bitcast and talk just briefly about endian. And I think this is another one of those things where for a long time, if you needed to know what the endianness of the machine was, you didn't get any help from the standard. Now you've got a simple enumeration that helps you do that. It's in type traits currently. It might be moving to bits. I'm not entirely sure on that. So stay tuned where it actually lands. But you can use it at compile time, which is interesting. So you can figure out and maybe do const expert code based on the endianness of the machine. And you can also use it at runtime. So, standard if-else statements, do something different depending on the endianness of the machine. So there's a bunch of stuff. It's already in the working draft. So this one will definitely be there. Other bit manipulation facilities you should know and love by now. STD bitset, dynamic bitset. Oh, look at that. I got 10 minutes on the clock and 10 minutes on the slide. It won't take 10 minutes. So we'll have a couple more minutes for questions. So miscellaneous topics, math constants. Question, how many people need pi and other math constants? Quite a lot. Interesting. So there's a new header called math. There's a new namespace called std math. And it provides a whole series of floating point value types to the nearest representable value for that particular type. I'm showing you long double. There's float. There's double. Incantations of these things. And so I don't think this is even the complete list. There's a long list of them. This will help you out when you're doing that. This has been already pre-reviewed by the library working group for Cologne. And Marshall's not here, but I thought he was going to try and have a list review so we could have it tentatively ready in Cologne so we would not have to review it. Obviously, Boost Math has these. One thing you're not going to be able to do with this is you're not going to be able to take your special big number type and just use these. You'll have to take whatever the supported double type values are here is all you'll be able to get out of the standard. It doesn't support customization for your own number types. A couple more math functions real quick. Midpoint. That seems like the simplest function ever, honestly. It turns out to be really hard. There's two different problems. There's the integer overflow problem. That's the primary one. And it turns out that Java had a bug in their pointer logic under the hood for a decade, apparently, associated with not calculating this right. And apparently, Mozilla's JavaScript had a problem with this function as well. So apparently, this is a lot harder to get right than it seems. It was also very interesting in Kona. We had a couple of two not be named, very experienced library development authors attempt to, on the fly, actually write this to the specification that's in the paper. By the way, this was brought by the national labs. And yeah, it's surprisingly hard to do. It took well over an hour to get an implementation that actually worked in all of the cases. It's surprising. So definitely don't write your own. In the same paper, there's linear interpolation, which is about the oldest thing in the world for graphing and other things. Why is that difficult? Well, I'm not going to explain it. I'll show you what the paper said. This is the set of capabilities that we want out of the linear interpolation. So for all of us non-mathematicians, it might take us a little while to actually come up with a function that actually is able to do this. So the interface is simple. Give it 3 floats and it'll linear interpolate in between. Okay, so there's the references. It's in the working draft. You're going to get it. And this is it. Last one, string and string view. New member functions, surprise. You didn't think that there would be new member functions in string ever again, did you? But there they are, starts with and ends with, something that's very basic and very useful. That's in the working draft, and you will see it. So, a couple of observations, and maybe I should have gone slower in bits, but anyway. There were 2 slides full of things I did not cover in this talk. I did not cover anything really with respect to ranges, concepts, any of that stuff in this talk. The library changes in C++20 are huge. There's a lot of them. Some of these things are really small, tiny tweaks on the edges, bug fixes, really good fix-ups, cleanups. Some of them are key building blocks going forward. I guess my overall observation here is that we're still in catch-up mode. Our standard library still has a lot of things that are missing for day-to-day programming that other languages and other libraries have. So it's great to see the progress, I think, in a lot of ways. In a lot of ways, it's not fast enough. But as been mentioned before, the committee has only so much bandwidth to actually do things. I think it's also the case that programmers only have so much bandwidth. So I don't know if a few of you have been intimidated by this talk and how much stuff there actually is to go learn about. I can tell you that it took me an extensive period of time to actually go through all these papers, to actually try all these libraries out, to talk to the authors where I could. It's not a trivial amount of stuff to learn, and this is only half of it. So it, I think, is going to change fundamentally the way we do a lot of programming. So I really like this quote from Henry Petroski on kind of a similar vein. Anybody know who Petroski is? He's a civil engineer, and he's written extensively about bridge failures and why they would happen, and engineering and so forth. And I thought this is particularly true because when I was reflecting on the number of decisions that had to be made to get the standard library to where it is today, even the language, of course, to where it is today, there had to be thousands and maybe millions, I don't know what the order of magnitude is, tens of thousands of conversations, tens of thousands of decisions. It's really a lot of stuff. It really is. So, okay, thank you. Questions? More questions? Give him the microphone. Yeah.
Is Endian merely for detection? There's no helper functions for managing byte order or anything like that?
No, there's none of the features that you have in Boost Endian that allow you to do those swaps and stuff now. So it is literally the enumeration that you saw on the slide. Yep. Mm-hmm. Vittorio, pass the.
So I checked span.
Okay.
There is an implementation in libc++ of
Okay.
the standard. And if you put const as part of the element type, then it's an immutable view over something. So you are free to choose between span of int or span of const int.
Okay.
And that determines whether or not you can mutate the underlying contain.
Okay. Well, it'd be interesting to check. Okay. Good. Good knowledge. And so is that already in a shipping version?
Yeah, it's in Clang, libc++. I don't know the exact version, but it
Okay.
works on Godbolt with trunk.
Okay, beautiful. Yeah, span's been in process for a while, and I didn't mention, I think also in the standardization process, there's a multi-dimensional span type for doing multi-dimensional arrays, and somebody that's doing linear algebra is probably interested in that kind of thing. Other questions? Yeah.
Maybe if there is no other questions, and you could go back to Unreachable. And,
Sure, let's go back to Unreachable. We can do that.
Thank you.
Oh, there. Okay, so what is it? It's a way to annotate branches that shouldn't be reached in code. And there's some thinking in the paper that implementations might provide modes where maybe you're going to trap, like a debug mode where you might trap an unreachable and provide a runtime diagnostic. Now, one of the things this is going to allow compilers to do in certain cases is optimize things. And it turns out that all the major compilers, I've just shown GCC here, but all the major compilers actually implement this already as an intrinsic. And so this is, again, lifting standard practice into the standard for use by developers. So this is the motivating example from the paper. I have a function f, takes an integer. I have two cases, and I have a default that I should never reach. Maybe we shouldn't get into why you shouldn't write your code this way, but in this particular case, yeah, you're able to call std unreachable, invalid value of x. Might be nice if you said what the value was that was passed in. But you're basically in undefined behavior here.
That string isn't used anymore. Like, what is that string for?
That string is for diagnostics. So if you're in some kind of a diagnostic mode, you might actually get that out of your terminate function back here.
So that unreachable triggers in runtime or at compile time?
That is looked at compile time. But in certain modes, it may trigger in runtime. But in this case, it might allow the compiler to say, I can never get any other values other than 0 or 1, and try and optimize away. So here's another example, which until I read this paper, I hadn't thought of this clever idea. To kill yourself, that's an interesting way to do it. There seem to be more direct ways to do it, but in this case, yeah, this line of code will never be reached. And so there's some couple of simple signatures. There's another attribute, no return. And this one still needs to be reviewed by LWG as well. Okay. All right.
The other slide you skipped was bits.
Oh, Bitcast? Well, now we're out of time. I wanted to get out of Bitcast. We can go there, though. So it's essentially a replacement for reinterpret cast or union. when you're doing low-level memcopy type capabilities. And so you have some memory, you copy it to another place, and you want to cast it into a particular type. It offers a little bit more safety in that the sizes and things of the two types that you're trying to cast have to be the same. This is already in the working draft, so you can go take a look at it. The motivation for this is a little bit obscure and sketchy in the documentation, if you ask me, but I guess I can see uses for it in particular where maybe you're taking something off a wire and you're going to cast it into a type. Yeah. Yeah, so the question is, what does it use inside, and is it reinterpret cast or compiler magic? And I assume since it's got to enforce, if you look at the working paper, you'll see it has to enforce some conditions that, well, reinterpret cast basically doesn't enforce anything, right? It just does what you tell it to do. And bitcast will enforce at least some conditions on you. So it has to do something a little bit more. Yeah.
Yes, so I have comment about bitcast. Actually, you can use it if you receive by network like some message in binary format. You divide it into like words, then you need to convert it from little Indian to big Indian, and then to convert it to the float or double.
Right.
So that's where you need bitcast.
Right. So you're basically operating directly on the memory there, trying to get it into the memory of the machine, and in that case, the sizes aren't going to change, or they can't really change. They better not change, because otherwise this won't work. All right, I think we're done. Time for the picnic.